Hello, everyone. Thank you for joining today's webinar. I hope each one of you and your families are doing well during these tough times. To start with, I'm really glad to know that we have a very dynamic audience today. I see a lot of folks who are senior managers and engineering consultants from big manufacturing companies who've joined as well. And also we have new engineers who are looking to sort of set a mark in this industry. So once again, my hearty welcome to all of you. So today we talk about how to effectively define the requirements to help you get organized for any machine vision projects that you may be currently handling or that you would be probably looking to handle in the future. So our preliminary observation is that a lot of people are prone to some of the common mistakes that result in failures to achieve their business objectives of a machine vision implementation. So additionally, we also noticed that the evaluation process of the various vendors, during the selection of the solution, unfortunately, at most times seems to be a little uninformed. So, as a part of this webinar, we hope to help you identify all of the considerations that you may need before making any decisions with regards to machine vision solutioning, so to speak. So, let's get started. So, I would like to introduce everyone to Mr. Raghava Kashyapa, the founder and CEO of Qualitas Technologies. A little bit about Mr. Raghava. So he's been in the industry from quite a long time now, and he's been helping clients with vision-based solutions from over 10 years now. So I hand it over to you, Mr. Raghava.
Thank you, Adi, and thank you everyone for joining in. I'm really excited to be hosting, I think, which is our 10th webinar, and the audience just seems to be getting a lot stronger. So it's wonderful to see you all. It's a commitment for learning. It's a industry and a technology that I'm so passionate about, and it's always great to share that passion with a lot of other people who are looking to derive the maximum benefit, and more importantly, really learn in this journey, because it's all about learning. And the very fact that you're here today shows your commitment towards learning, and I hope you'll all take away something which is going to be of value to you. I'd like to do a small introduction about myself. So you're going to be listening to me talk for about an hour, maybe more. So I think it's fair that you know a little bit about why you should listen to me and spend your valuable time talking and listening to what I have to say. So just a brief background. I have an academic background in electronics and computer science as a master's from Washington State University. I happen to specialize in artificial intelligence. Right after my academics, my next stint in my career was to actually got sucked into the startup world, and I did a couple of startups, and some of it, one of which did really well in the health tech space. And I learned quite a bit from a small company to a few people which grew to a few thousand people. I then went on to the corporate world, and I went to the other side of the spectrum, and I got a fair stint at Microsoft in the US, where I was working in AI again, search technology, mobile technology. That was quite hot. But I think it was just in the back of my mind, I always wanted to be in machine vision and AI. That's something that I had gotten interest from right from the college days. And then I wanted to see how I could take this to something that could be beneficial and really drive business value out of the technology. So it was mostly in research labs, especially AI technology was mostly in research labs and academic centers. But it was something that was inevitable that would make its way into the mainstream. And I think unless you've been living under a rock, I'm sure you'll agree with me that AI has really kind of created the tech buzz of the 21st century is really about AI. And more recently, I think in the last 5 years. And so as in the latest avatar, I've been the founder and CEO of Qualitas Inc., which started in the US, and then we relocated back to Bangalore, which is our headquarters. And right now I'm running Qualitas Technologies. And we've been primarily in machine vision, and more recently machine vision specializing in AI technologies. But more importantly, I've more than all these things, I've been a constant a student and a learner, right? And I think that's what's really been my signature calling card. I've been, an avid learner. I attend a lot of technology webinar. I talk to a lot of people, and I'm really humbled to actually be on the other side of the spectrum to really share with you a few knowledge, tips and tricks about what we've been doing and what you've I'm again thankful for all of you to listen in and actually hopefully take away something of value. And so from what we've seen, there's been a fair amount, fair diversity in the target audience. So especially in the manufacturing industry. And just to get to know the audience a little better, I would love to, get a sense of who is among the audience. So, we have a small poll that if you could just answer a quick question, whether you're a manufacturing, from the manufacturing industry, or whether you're from a system integration background, etc. Not this one, the other one. Okay. Yeah, just type out in the chat window, perhaps what, if you're from manufacturing, just type out M, if you're from a manufacturing company, right? In the chat window, just type out M. Or if you're SI, then type out SI. And if you're a student, then type out S. Yeah. Okay, a lot of students, system integrators, a few from manufacturing. Okay, wonderful. So, great. Okay, so that's the intended audience. Now let's, Now, I'll talk about a little bit about who this webinar is for. Now, I've seen a diverse set of audiences about how aware they are of technology, especially in machine vision AI. And I've come across 5 different segments. So, in the first one is you've never heard of machine vision and AI and have no idea what this technology is about. Right. And, that's fair, especially AI, I think everyone has heard of, but machine vision and AI, I think that's fairly new. And so it could be something new that you've seen. Now, the second category is you've heard of this technology and you're wondering how you can apply this in your manufacturing line. So you've either read about this or you've heard about this, and then you're just wondering, okay, how can this be useful to me? Now, number 3 is you've actually seen this technology, you've seen it in action, and you're convinced that this will work, but you haven't quite experienced it. You haven't started anything practically. And that's the third category. Now, the fourth is you've actually deployed your first machine vision system, or you've deployed a few machine vision systems, but you've not had a great experience and seen compelling ROI. So either, it's not worked for you, or you've not, you've tried it, but you've not been too excited about it. And you've said, this doesn't actually, it's overhyped. And the fifth is you've kind of hit the holy grail. You've successfully deployed multiple systems, you've derived business value, and then you're now looking at more advanced technologies. So you've done some basic applications and you want to really look at, what can this do for you? So this is actually where the poll, we'll have a small poll. And if you could take 2 minutes to just quickly type out, what is your. So we've got 7, 8, okay. Mostly in the second category, it looks like. So you've heard of this technology and how you can apply this to manufacturing, right? So many are a few advanced users as well. Great. Yeah, please use a poll instead of the chat. I hope all of you can see the poll. I've seen about 70% of you respond. We'll give it another 15 seconds, sorry. Okay. All right. So let's get that. So yeah, looks like, most of you are in the second category, and some of you have done, a few of you have successfully deployed. That's very exciting to see. So a few others you've convinced that this technology works, and okay. Very good, very good. Okay, so that gives me a little bit of idea. Now, okay, so let me also tell you then, this topic is mostly for 2, 3, and 4, right? So where most of you are I think more than 80% of you are in that category. So it's not going to be a very basic introduction about machine vision and AI. We're going to just give you a very brief introduction, but we're going to really dive into a more practical implementation as to how you can start to experimenting, or how you can actually start implementation of this technology in manufacturing. So especially if you're an Indian audience, this is specifically for you. I've seen, at least from our 12 years of experience, evaluating about 1,000 different applications, deployed more than 150 different production level systems. We've learned quite a bit. And I've also seen that the geography, the target, we've also worked in Asia Pacific, Europe, but primarily with India. But we've seen a significant difference in sort of, I would say, the technology adoption curve in the Indian geography. And so I think the audience is primarily from that geography and belong to these 3 segments, then this webinar is perfect for you. So let's dive right into what you're going to learn from this webinar. So there are 3 things. One is you're going to be introduced to the machine vision and AI. It's probably a very brief 1 minute, 1 slide introduction, couple of slides, not too detailed. I've got a lot of other webinars and videos where I go into the details of this. So if you haven't seen it, please check out our video list in the chat window. Adi or Amardeep, who's helping me run this webinar, if you could just send out a link in the chat window to a resources page on our Qualitas website. You can go and fill up a quick form and then watch all our previous webinars that we have conducted. So there's a lot of information about what machine vision and AI can do for you. But really it's about the second and third, which is the preparation guide. So tips for your organization for starting a transformation. So I call it a transformation, and I use that word deliberately because the journey towards machine vision isn't really about implementing a project. It is really about transforming your processes and transforming yourself into more of a digital driven organization or team. So there's a few things that we've learned, a lot of things that we've learned the hard way, but a lot of things that we've also seen success out of. And so I'd like to talk to you a little bit about how you can start preparing for this transformation. The third is then actually getting into the implementation. So here we're going to get into really practical steps as to how you can really start with implementation of a vision system and what you need to be doing to keep in mind to ensure that you're successful when you get started with your first project. Sound good? And if so, then let's go right in. Okay, so you see the link is on-demand webinars. Please feel free to check that out. Tons of good material out there for you to see. Okay, so brief definition of machine vision. What is machine vision? Machine vision is the process of acquiring digital images. This is a very simple definition. And so we acquire digital images and then we compute a result, right? So this definition is carefully chosen. It is a digital technology. So we do, and it is automating a certain process in manufacturing. So what could it be? It could be anything that a human or something that's being done manually needs to be then automated by computer vision technologies. So that's the definition that I'd like to use. So again, machine vision is the process of acquiring digital images and computing a result. It could be a defect identification, so it would be OK or NG. It could be reading a character. It could be measuring something. So it's computing a result to automate something. That's the idea. So in other words, if I were to show a picture, you're kind of moving from this. Let me just use my cursor here. Yeah, you're moving from something like this to something like this, right? Which is really automating an inspection task or anything that was done manually. Okay, so right. Oh, let me just clear that out. Okay, so what are the different applications? And broadly speaking, there are a number of applications that you could use this technology for. And it's detecting objects. So if you have a specific assembly, you want to detect certain objects, maybe counting or identifying if there's a specific part that needs to be in an assembly, then you can detect an object and then compute a result, whether that object passes a certain quality check or not. The second is measurement. So as the name suggests, it's gauging and measurement. So you're computing a physical dimension like the width or the depth or the diameter, some physical geometry that you're trying to measure from an image that you've captured. Flaw detection is an anomalies, scratches, dents, cracks, things like that. A number of these processes involve flaw detection to ensure as part of quality control. So that is a classical use of machine vision. And of late, AI and deep learning has made this even more popular because it's what was earlier very hard to do with rule-based programming. You could now automate this very easily with AI-based systems. A specialized form of flaw detection is print defect detection. So this is a much more specialized application where in high-speed printing or packaging, you're looking at graphics and artwork on print and identify minor flaws. So, it could be print smudges, or it could be, ink that is missing. There's a different coloration, discoloration in the print, etc. So these in all these packaging lines, it's quite common to see these print defect identification systems that are running. Identification is to identify specific object, and here identification either involves reading a barcode or reading a serial number to identify the specific unique code or part number, if you will. So typically these are more standardized systems. So you have image-based barcode readers that's also using machine vision technologies, but the application for that is identification. Locating is locating a specific object. So the first one was object detection, which is to detect it. Locating is identifying the position of the detected object. So you're identifying it either to pass on a coordinate to a robot so that you could use robotic guidance to pick up a specific object, or to place a specific object in an area. So that's a classic application of locating. The next one is classification. Classification is really to identify and tag a specific image. So you see an image that's been captured, And it could be maybe to identify mismatches. So you want only a certain type of SKUs or certain type of variants to be moving in your material handling line, assembly line. And if you see the odd man out, if you see some mix up, then you could use a classification kind of application to detect these anomalies. The last one is OCR, special form of identification. OCR stands for optical character reading or recognition, and it's nothing but reading machine printed data that is either printed by a laser printer or an inkjet printer, or even some engraving that's done on maybe an engine assembly, like the vehicle identification or the VIN number. Those are printed on the engine blocks, and if you want to read that, you could use machine vision for that, using OCR technologies. So that's about a basic form. So again, I'm covering this very quickly. I'm assuming you know some basics about the technology, and what so why should you care right now? And here it gets interesting. So why should you care, and why are you here, for instance? Why are organizations really looking at this from a strategic standpoint? It starts with what you term as the total cost of quality. Now, this is a definition that's being used quite or a measure that's being used in the industry domain quite a bit. And it's a metric that measures basically what is the cost incurred by an organization to manage quality within a manufacturing organization, right? Now, if you look at where quality spends occur, there are really two broad areas. There are areas, processes, and investments done in preventing quality defects, quality issues, and those are called prevention costs. So you're really trying to prevent the defect from occurring. And prevention is better than cure, right? But sometimes you do face quality issues, and the cost then to mitigate the occurrence of these defects once they have occurred are the mitigation costs. So there's really two broad categories: the prevention costs and the mitigation costs. And let's look at some examples of what are prevention costs. So appraisal costs. So you have human inspectors today, they're appraising, or they're looking at every part being manufactured, or sometimes they're sampled. And you're trying to identify, okay, is this part okay before it moves on to the next process? So you're not doing any value addition or further processing if something is out of place. So that's the appraisal and the in the prevention costs. Another is quality assurance planning, right? So you have plans, you ensure that you have processes and you have poke-yoke systems in place, and you're really doing preventative measures and steps in your production process. And quality planning, of course. So any planning that needs to occur, how you would prevent maybe incoming from your supplier end, those have to be planned and included into your quality assurance plan. Mitigation costs are then, again, there are two kinds. There's internal failure costs and external failure costs. Internal failure costs are costs incurred after a part has failed or detected as failed within the factory before it reaches the customer. And these are, maybe rework costs. If some defect is found, you may have to incur some cost to rework it. You may have to just scrap it. You may have to dispose of it. So all those are internal failure costs. External failure costs are, more related to, okay, once the defective part has reached your customers, and you are incurring penalties, recall, warranties, returns, and more importantly, reputation, right? So I think it would be fair to say that the earlier you detect these defects and quality issues, the more you're going to save, right? So mitigating these, the less you have to deal with external failure costs, basically in this region is where you can really improve or reduce your total cost of quality, because these become very, very expensive. Okay, so I see a few questions, and we can maybe look at that as well. Okay, so Radha is asking, would it work on image data set for weather forecasting? Okay, yeah, machine vision could be used for weather forecasting. That's an interesting one. So I'm the main domain that we are covering today is manufacturing. It's industrial, but yeah, computer vision by itself has broad applications. But I confess I have been restricted in manufacturing 10 to 12 years of experience. But yeah, weather forecasting, I haven't heard of any applications of how vision could be used for that. It's mostly satellite images. Would it work to automate key moments of any sports video? Automate key moments. Not sure what that means. Automating a moment of a video. Maybe rather if you could elaborate on that question. Okay, so check components having only one opening at one end. Whether machine vision can be used for dimensional accuracy check of components having only one opening. Yeah, so machine vision usually is, the basic premise is it uses what is visible. So what's visible is what you can inspect. So if you can't see it, there are some probe-based or whole inspection kind of lenses, but they're not typically used for measurement, because for measurement, you need to calibrate your lens and your vision system to a very high accuracy. And so unless you can see it, it'll be pretty hard to measure. Yeah. Okay, so now let's talk about what these numbers are, right? So the total cost of quality, there are studies that show it can be as high as 15 to 40% of a company's turnover. That's a humongous number, right? So that's according to ASQ.org. So companies are spending 15% at the minimum and up to 40% of their turnover on your total cost of quality. And so there's definitely some, even a few percentage points there mitigated can translate to huge savings, right? So that's one mind-boggling stat. Now let's look at how this is done today. So if we're talking mostly about these preventative steps, and the preventative steps today is actually human, manual processes. Most of these prevention costs that you're talking about is manual. And so if it's manual, then it's also slow, it's unreliable. Studies have shown that 80% of errors are due to manual processes, 80% of your errors. They're expensive because you have a lot of people involved, the costs, and to ensure that because you cannot do 100%, oftentimes companies use sampling, right? Sometimes it could be unsafe because there could be areas where it's not safe for humans to be operating in. And then there's traceability issue because it's manual, people are looking at it, there's no record of something being inspected, there's no digital storage, it's not convenient. So clearly quality control needs to be automated, and that's really the why. So, and the primary technology that's very popular today is machine vision, right? So now you've got a sense of the why, but how, right? Now how does one start? What does one do? And here it gets interesting, right? So like I said, we've studied over 1,000 applications. We've talked to a number of, over 150 actual successful deployments. And we've tried to distill a few common themes around what works and what doesn't work in machine vision, not in terms of the product and the solution, but because of the approach to implementation. I'm talking about the approach. And this is where all the manufacturing companies in the audience, system integrators, etc., this is for you. It's how do you actually think about this, and how do you prepare for actually successful implementation? And the number one thing is they treat this as more of a project rather than a transformation, right? So this is not where you just go out and seek a magic bullet solution. You Google search, you find a vendor, and you tell him, hey, I have this defect, I have this part, now figure out a solution. It doesn't work that way. If that's what you've been doing, let me tell you, stop. It's not going to work. You're not going to get a magic bullet solution from a vendor by just translating your existing manual processes into automation. You have to follow a certain process. You have to follow a small roadmap before you can actually start implementation in your line. Now, what is that? What's that roadmap? And it's really 3 steps. So the first step is in preparation, right? There's a number of things that you can do to actually prepare for a solution. And this is something that you have to do. The vendor will not do for you. Or even if it does, you will not get the right solution. Because you know your problems well, you know your manufacturing lines well. So you need to articulate and get into some of the details and prepare for any kind of automation that involves machine vision or AI. And I'll talk a little bit about what you need to do there. The second is evaluation. And here I'm talking about technology evaluation, because one of the most common trends I've noticed, or one of the drawbacks I've noticed, is when we talk to customers, it's mind-boggling as to how limited their knowledge is in terms of such expensive technology. So they're evaluating solutions which, based on the requirements that they have, is going to be mind-bogglingly high, very high in terms of investments. So I often wonder, so if you're mandated to install or to automate something that's going to cost crores of rupees, right? You need to be educated on, or you need to know the basics of that technology, because it's never going to get management approval otherwise. You'll never be able to convince your approving authority as to how you're able to translate that into benefits. And I'll talk a little bit about, how you need to match the business value with the investment. So when you invest something, be it, even 1 lakh, 5 lakhs, or even 1 crore, anyone making that investment would seek to see much more of that investment as benefits. Now, if you don't know what your benefits and the goal is going to be and how to match the investments to be under that benefit, you can't spend more than what you can get out as part of return on investment. The return has to be more than the investment itself, right? So that evaluation, matching the problem and the technology, is the biggest gap I see why projects fail to take off. They don't even realize the first step in terms of implementation. And the last step is when you have a problem, you have a solution that matches the problem, is then you want to implement it right. And here again, there's a few steps that we've seen why implementation fails itself, and you're never able to realize the planned benefit that you had intended for that system. So let me zoom in a little bit on all these steps. Right now, what is this preparation step? Now, and most projects fail at this step, and it's quite common to see. The main reason is identifying the right problem to solve for machine vision. Oftentimes, we get problems which are not suitable for machine vision at all. Now, if you're looking at the problem, you need to at least be educated enough or trained enough to be able to match, okay, this is a machine vision problem, and this is perhaps a laser or a sensor problem, or this is not suitable for machine vision. So some common examples I get is extremely high accuracies, which cannot be solved using machine vision, right? Which you need to have different technology for, or you can't have inline machine vision solutions for. The other one, which requires, X-ray, things which sort of is not on the surface level defects, things which need to go beyond the visible surfaces. So there are some very advanced technologies, but if you've not implemented any of the basic technologies, you don't want to be jumping into something that's so advanced. You want to start getting warmed up first with something which is very easy to solve, some low-hanging fruit, derive some quick wins, and then go into more complex applications. So it's really choosing the right problem, and it's not just problem which can be solved using machine vision from a technology perspective, but more importantly, that can derive business value. So I've seen some applications where the benefit to automating this is very low. So why would you invest so much of your time analyzing a solution or exploring a solution for something that you're going to get very little benefit out of? It's not worth it. So you have to match the right problem with the right solution, and the right problem is both from the technology side and on the benefit side. So a couple of things that we would do is we walk through a very detailed questionnaire, for instance, to ask, okay, what is your business goal? What is your business objective? And oftentimes we get answers as to, no, I want to automate this. Yes, but why? Why do you want to automate it, right? And then they say, because it's manual. I said, so what if it's manual, right? What problems are you seeing if it's manual? Are you actually seeing, is it a manpower cost reduction that you're trying to do? Because if the benefit that you're trying to realize is purely saving on appraisal costs, then that ROI, at least in India, is very hard to realize because manpower is still cheap. But if it's to increase your cycle time or to decrease your cycle time, increase your throughput, manufacturing velocity, then we get into details as to, okay, what is your velocity today and what's your target velocity? And then what benefit can you see in terms of business justification? And that will give us a number that says you're probably going to save 10 lakhs per month. And that will justify an investment if you're looking for a 1-year ROI to say, okay, there's 1.2 CR of investment might justify this business goal. So we need to really understand the business objective before we actually dive into and look at what is my ROI, what is my investment range that justifies this investment. The other aspect of this is it requires machine vision isn't, at least for advanced, I'm not talking about very simple smart vision camera systems. There's a number of smart cameras which do simple tasks, identifying an object, identifying something, very, very simple vision sensors, as they're called. I'm not talking about these. I'm talking about, something that would be slightly more complex than that. And for that, you need to have a specialized team. And the reason you need to have a specialized team is that it's not going to be a plug and play solution, and the product vendor or the product OEM is going to come in, give you a solution, and that works forever. You still have to maintain it. You still have to make sure that it works. Tomorrow you may have a different variant, and the responsibility will still come to stand on your shoulders. So you need to assess stakeholders, their needs, in terms of if the end user is manufacturing or quality, what benefit are they trying to derive out of it, and what maintenance and implementation steps do they have to do to be successful in the final project. It also involves some skill assessments. You may not have worked with machine vision before, so it's better to maybe take a small training or do a practical training as well to understand just the basics about what is maybe different types of camera systems. What's an area scan camera? What's a line scan camera? What's a frame rate of a camera? How it's not just about cameras, because this is another important aspect I see. People think machine vision, it's all about camera. What resolution and what camera are you using? But a camera is actually a very, very small, insignificant portion. It's just to acquire images. And today with AI technologies, etc., you can use the cheapest of cameras and still be successful. So it really depends on the application. Sometimes the optics is very crucial, matching the right optics with the camera. So you don't need to be skilled enough to implement a solution, but you need to be skilled enough to evaluate a solution. There's a big difference between the two, right? The skill to implement and be successful, and the skill to be able to look at two different solutions and say, yeah, this is better than this one. So, and I see this quite a lot as well. People are comparing apples and oranges. So they have a vision camera, and then there's a very advanced AI-based system. And they say, oh, but this vision camera costs 50,000. Why is this costing so much, right? And they are apples and oranges. You can't compare the two. So you need to at least know, and sometimes you need an apple, sometimes you need an orange. I'm not saying you need to always pay more for a very simple application, but you need to know when and how to compare two different technologies, because there's a wide range of solutions available in the market. So that's the preparation step, is training, is analysis of the problem, of the team, and then skill enhancements to understand what is, which technologies are suitable for your applications. So, this is a small case study. We worked with, as you know, ITC. Anyone from ITC in the audience here? If so, yeah, okay. But so we work with ITC there. As you know, no introduction required. Now, for instance, ITC has deployed a number of machine vision systems very successfully. So they would be actually the scale level, but still they recognize that that's just the tip of the iceberg for them, and they really want to take this to the next level. So Qualitas is working with them on training the maintenance projects team on the state-of-the-art machine vision technology. So, what is AI-based machine vision? What are some of the basics? So what they really want to do is they want to train all their team members, the project team members, on what is the basics to be able to do that analysis step that we talked about. So when they're going through their transformation journey, they are looking at, just a second. They're trying to identify, which problems are suitable, which is not, how to do business ROI calculation, which technology to evaluate, how to evaluate different solutions, etc. Yeah, sorry. So that's the preparation part of the process. Okay. The next step is then evaluation. So here you have identified a particular problem. So let's assume you've got the right problem that you want to solve. You have the business ROI clearly defined. You know that this is my goal that I want to meet, and this problem can be solved using machine vision in principle. The next step is then evaluating the technology to match the problem with the appropriate technology. So in other words, do you want to go with a simple smart camera based system, or do you need to use a more advanced imaging system? Do you want to use, do you need AI or a rule-based approach, right? So if you don't know what the difference between AI and rule-based, you need to educate yourself on that, because if you're evaluating this, there's a world of difference between the two, and how you implement it, how you actually maintain this. And again, it's educate yourself enough to be able to evaluate, not to implement, right? That's the key. And another thing is the implementation strategy. And here is where I've seen a tendency to play it really safe. Now, what do I mean by that? So the common ask from most projects is to say, I want one vendor to do everything. You have products coming from one side, and you get this segregated on the other side. That's it, and a black box, and I don't care how it works. And they have a very specific part, they have a very complex geometry, and it requires, complex material handling, it requires complex imaging, it requires complex processing, and then it requires, complex control system implementation. Now, the chances are you getting a single vendor that has expertise in all those different areas and has done this before is probably 1 in a million. So you're stuck with just there. Right? You're stuck with a very high requirement criteria that says, I want this from one vendor, because if I split this up, then I don't want to get into the situation where one vendor is blaming the other, who says, oh, the material automation is not working, and the vision system guy says, there's something wrong with the control system. And the automation guy says, no, the control system, everything's fine, but the vision system is not working. So that's their biggest fear. So let me tell you, right? So now it's okay. It's okay to split up expertise, because automation and AI, for instance, are worlds apart. It's unlikely you're going to get somebody who will have expertise with both. And even if they do, it's going to be likely, like what we do, for instance, we work with automation partners. We don't do this in-house, because an entire team of 50 plus engineers know vision really, really well. They know enough to evaluate and work with partners for automation, but we wouldn't claim expertise in very complex material handling and automation tasks. Now, if we work with a partner, we're going to have our overheads and our inefficiencies, because we are not experts at that. But if we get only a machine vision scope of work, we would be very efficient at only solving that, and you will get the best ROI. So so if you actually plan your implementation strategy so that you can actually split unrelated technologies like automation and AI, you can actually minimize your investments. And it's a trip, because you can get one vendor. There's specialized low-cost automation vendors who can do fantastic automation at a very low cost to just move material from one place to another. And all you need is just moving it consistently so a camera can take an image. It doesn't require a lot of sophistication. It doesn't require any knowledge about machine vision. But if you can do that, if you're brave enough to say, yes, I will get this done by this vendor, and I will only source the specialized vision solution through another, you'll be surprised at how much you can save and how you can implement this at a much better quality than trying to get everything under one roof. Because then it sounds easy, but it'll never take off, especially for complex applications, because it'll be too expensive or too complex to manage. So don't be afraid of that implementation strategy. And a lot of people also do things in-house, and especially for certain applications, like for simple applications where only vision sensors are involved, you don't need a solution to be provided by a vendor. You can actually get the part, you can install it yourself, and you know how to do this. And that's where they've seen their most successful implementations and adoption of the technology, is how skilled the team is on the manufacturing side. Now, last but not the least, the evaluation. If it's something new you're trying, do a demo, do a POC. And another thing is, don't expect free POCs, free demos, right? So even if you get something for free, it's not going to be doing justice to, it'll only tick a checkbox that you said, yeah, I've done a demo, but it doesn't really do justice to your problem. You want to do this on the line, you want to do this on your actual problem, and you want to be able to convince yourself that this is worth investing in for the next step. And don't expect ROI with the POC. The ROI is not going to come from a business value, it's going to come from learning, right? You can't put a price to that. So that's the implementation step. And so this is a case study. Again, we worked with LM Wind Power, acquired by GE Renewable, and then they have they're very advanced in terms of the technology. They look at various improvements, and they're exploring non-contact based imaging technologies to automate inspection of their turbine blades. So what they've done is they've explored various options, right? They've done numerous POCs, and they've not really started on any large-scale implementation, because they've realized that they need to really explore, look at different various ways to solve this problem, and they've gone before they go into any kind of optimal implementation. that works for them. And so we've been working with them for some of these concepts, and we've seen really good results by adopting this approach. Okay, so so now you're ready. So you've done your preparation. You've now gone into your evaluation of the technologies, etc. You've even done maybe a POC, and now you're ready for your first pilot. So remember, a lot of times people just jump to step 3 without going through the first 2, and they never get anywhere. So the pilot is then the first project for a given technology, some new technology, especially in vision and AI, where you're able to actually get some kind of business ROI. So here you're going to be, doing vendor selection. You're going to be looking at which is the right vendor, and you're skilled enough to be able to evaluate different vendors' proposals, right? So you're going to be exactly able to pinpoint what are the pros and cons of proposal A versus pros and cons of proposal B, and you're also able to identify a success metric, not just tied to accuracy, but tied to on a business metric. Like the example that I talked about, where you're trying to increase your production volume or reduce your cycle time. So whatever it is, you have, tied your problem to the business metric. And then finally, you have a long-term assessment plan. So because the pilot is really your first project, and there will be hiccups, and you need to put in an assessment plan to monitor the pilot for at least some amount of period for stability. Because when you roll this out in a larger scale, you're going to take all the learnings that you got from this pilot and implement it on the scale project. So after the pilot, you will then do an assessment. You will evaluate the pilot. Now, as I said, there'll be hiccups. You need to have a projects team tagged to that, to managing these hiccups and mitigating these, and then evaluate your business ROI and identify improvements. And then, of course, with all these improvements, you'll be able to negotiate with vendors and update your RFQ to incorporate the above learnings to be able to do a much, much better job during scale and rollout and get even better ROI on these implementations. So using this approach, we've seen a lot of success. It's a transformation. You don't see success right away. Instant gratification is a rare thing, but using this approach, we've seen how organizations have been able to scale and see amazing benefits. So now let's look at a Gartner study, a Capgemini study of this was pretty interesting because this is a global audience, not in India, but in manufacturing, more than half of the companies fail to progress after a POC. So, this goes to show that POCs are trials, and many of them, they try things out, it doesn't work. But unless you try, you never find the right recipe for success. And, the green are organizations that actually successfully deployed use cases in productions and continue to scale. And this is across industries, but I've just highlighted the manufacturing sector. So about 6% have really gone into scale. So this is Europe, right? And in India, we're still lagging in terms of the technology adoption. And so but the journey is the same. You need to prepare, you need to evaluate, and then you're ready for scaling. I have a few more tidbits and tools and resources to share with you. But before I get into that, I just want to stop and take any questions if there may be any. So, feel free to type out any questions you have in the chat window. I'll be happy to answer this before I move on. No questions. Okay, great. So, there's machine vision can identify inner of HDPE bottle. What is HDPE bottle? Not. Could you expand on that, Praveen? Okay, so let's move on. Tips and resources. The first thing that we use is this nifty requirement analysis tool. So it's a web application that we've developed here at Qualitas Technologies to actually define requirements and design. And actually, let me show, I would love to show you a brief, maybe a small demo of this, so you get an idea of. So this is, not even to develop the solution. It's actually to gather requirements, to analyze your requirements and your problem. The first step. And okay, so what I have here is a listing of all the different projects. And so let's look at maybe one. Now, we've developed this tool over, like I said, just to gather the preliminary information, in the requirement phase, so that we can derive suitability and assess any applications based on some parameters that we see very common among all the different applications that we've seen. So let's say, you're Toyota and your product that you want to inspect is an engine block. And so you'd go in, you fill out engine block as your product name, and then you'll say, okay, what is the rough geometry of this object, whether it's rectangular or circular. In this case, I'm going to say rectangular, and then I put in my minimum and maximum. So if there are two different engine variants, what is the minimum dimension and the maximum dimension? So let's say this is about 400 and 200 in width and a depth of about 250. And the maximum can go up to 700, 900, and then maybe a depth of 300, right? Then we capture some product images. We can go in and then put some images to give us a sense of, okay, how that engine looks like. And then I can put in different model names. So let's say the Toyota engine here, there's an Innova engine, and maybe a Fortuner engine. Oh, Fortuner the same, maybe the Camry. Okay. So I can actually go in and then put all those different variants in there as well. So now, so in some cases, if it's not just, I just want to, I hope everyone can see my screen. I did forget to check. Are you seeing the application, the web application, which says Toyota? Yes, okay, wonderful. So in some cases, we go, it's not just the model, but you also have different variants in the SKUs. So basically, there are some minor variations with that model. So for instance, it could be an Innova, could be, in this case, it doesn't apply, but you could have a diesel engine and a petrol engine. So you could have different variants. It looks exactly the same, but, maybe except for a certain engine configuration that's present. So here you can actually go in and then list out all the different variants, and you can also upload an Excel file which has a CSV separated list of all the different models. Now, the next step is in identifying the requirements. So here you have different requirements. So let's say I want to do VIN OCR. So VIN reading. So I want to read the vehicle number on this engine body. So read the VIN and communicate the signal to a PLC for verification. Now, in this case, then you would choose your requirement type. So is it a classification, object identification, defect identification? It's optical character recognition. So I'm going to select optical character recognition and then create this requirement. Now, let's say I have another requirement as well. So in this case, I want to make engine assembly verification. This is to check the piston ring placement as well as circlip presence, right? So in this case, I want to check two different things. I want to identify whether there is a piston ring that's present on the engine, and then I also want to check if a circlip is present on a specific area. So in this case, it's not really classification, it's not defect identification, it would be object identification, because I want to detect the presence of two objects. So I'm going to go ahead and then create this requirement as well. So now I have wind reading and engine assembly. So as you can see, these requirements get created, and now here I get the details about that. So when reading, I'm just going to go ahead and type that out, and then the field of view. Now I've asked the field of view. Now the field of view, you also get a little bit of help here, where you can actually check what you need to fill out here. But it's basically the horizontal as well as the vertical. So how big are your characters? The field of view the camera needs to image. So it's probably about 150 mm, and vertically maybe about 45 mm. And then I'm going to ask, what is the working distance in terms of your min and max? So let's say you have a certain overhead constraint, overhead conveyor, where the tool, is hanging. So you can't go beyond that. So the max working distance that you can go is about, 500 mm. And then you also need to ensure that the workers are able to work and do the assembly. So you cannot, you need to have a minimum as well. So you can say there's 200, that gives me enough space to be able to have my workers work on this at the same time it doesn't hit the ceiling. So there's a number of these. So minimum feature size, how is it carried out today? What are the drawbacks of the current process? So remember the problem analysis. Then you actually have the model selection. So maybe it doesn't apply, this vehicle wind reading doesn't apply to certain models. So you can uncheck or remove certain models. And then you can also set cameras that says, okay, now practically speaking, I need to have a top view to read this. So I can have a top camera. If I want to add another camera, because now I want to check something on the side, then I'll go ahead and add another camera. And so I can create this pretty, it's giving me an error, I haven't filled that out. It gives me a very objective and organized way to provide all those details. Now, then you have pre-inspection automation and post-inspection. So, what is your moving condition? Is it moving or is it stationary? You can upload a video. What's your maximum production speed? And then what's your acquisition trigger? How are you going to acquire those images? So these are all the different details that we capture, which are really important before we even get to any kind of design or solution. Post-inspection again, what kind of result would you like to see? Do you want to see a digital interface with a PLC or a controller? Do you want to see a buzzer? So what is the output? Do you require automation like rejection? So it really helps you capture all the relevant details before you can actually go out and seek a solution that you would want to automate. So I just wanted to give you a brief preview about that. Let me go back to the presentation here. And that's really the web application, the requirement analysis tool. So that we've developed, which you can actually use to, identify a requirement. So it helps, especially in these times where, visits are minimized. You're not able to make visits. Nothing beats the actual visit to a factory, but this is the next best thing that we could identify. All right, now we have another great offering as well, and so in addition to these tools, we've also come out with a brand new offering in terms of how we can partner with you on this transformation journey, right? And as we've talked about this whole process of evaluating, providing different solutions, is a journey and not really a project. And we've offered a brand new consulting service that we are looking to launch. We've not yet launched this. We've done a few pilots, but we're looking to offer this in the mainstream. And this involves walking you through all the 5 steps of this journey to derive maximum benefit out of machine vision and AI, the latest and greatest technologies, and how you can successfully see business value. I'm not talking about automate a task. I'm saying bottom line dollars, bottom line savings, of how you can actually see, tangible monetary benefits. And in order to do that, we've taken all our 1,000 plus deployments and analysis, our 150 plus inspection deployments that we've done, and we've packaged this into a roadmap and a journey that we've also put together as a package. Now, it starts with this on-site consultancy. So here, a business analyst as well as experts in the industry is going to come and spend 3 or 4 days in your manufacturing line, and they're going to walk you do this problem analysis step together with you. And here they're going to look at ROI. What is the return on investment? Is this problem? They're going to look at 3 to 5 problems which are suitable for machine vision and which you can derive benefit out of. Then they're going to look at what is the ROI for each of these. How much is it worth spending and investing? And if you do, what is the return on that investment you're going to get? Then they're going to do a team readiness assessment. Is this depending on what your team's level is in terms of technology adoption? We're going to do a gap analysis with the required skills and the assessed skills. And we're going to actually put together a very comprehensive training curriculum as well, which ensures that your team is now trained in terms of what is the right skills to evaluate all the different relevant technologies for your business. So not all technologies are relevant for your business. So we're going to look at what is relevant for you, what skills does your current team have, what skills they need to have, and then put together a curriculum in this on-site consultancy. And then we're also going to draw out a roadmap to say, what are the next steps? Like, what are the actual training programs that we need to have? What are the POCs what's the low-hanging fruit project? So among 3 or 4 different problems, this one is the least, this is the lowest hanging fruit that you can derive some quick win out of. So we're going to identify that as well. Now, the next step is then the training part. So this on-site consultancy is the first step. And like I said, we're going to draw out the roadmap for the next few steps and ensure that you progressively move from one step to the other, from preparation to evaluation to implementation and scale and deployment and maximizing our benefits. So, and then as part of this also, we'll be giving you all these free resources that we've been talking about as well. And we've got an offer that is right now, as I said, we're piloting it, we're evaluating this, we just launched it, and we want to offer this at a 50% discount for the first 10 registrations. And we'd love to spread the word if you're or somebody in your organization is really interested. Now, let me talk a little bit about the value you're going to get, because we've seen that if you don't do these preparation rights, the worst case is you never make progress. You'd only be evaluating, you never see anything actually successfully get deployed. Now, the worst case is you actually go and implement something completely which doesn't give you value. You spend upwards of 10 to 15, 20 lakhs on a solution and you don't see any value at all. Now, if you can just spend a few lakhs to get prepared, get trained, you can save 10s, 20s later. That's number one. Secondly, you would have a very strong roadmap as to exactly how you need to progress towards your transformation journey. And this in itself is worth 10 times the consultation charges that you would actually have. So we are offering that as a 50% discount, so less than a lakh. And I think we're launching this. We've just launched this in December. We've piloted with a few enterprises in manufacturing, and we want to spread the word. So I really do hope that you take advantage of this. We'd love to work with you. Thank you. I hope you got a preview, got some learning out of this. And remember, this is just a preview, right? So in a 1 hour, this is a very complex topic. I can just talk, 4 full days on just AI alone, and maybe another 4 days on just different aspects of machine vision, and it'll still not have scratched the surface. So remember, it's a journey, and we are happy to engage with you on any parts of the journey as well. And I thank you for taking the time in the evening to spend the time with us here at Qualitas, and have a great evening. Thank you so much.